Okay, so if you've done the second one, same thing for the third. Again, trace the reflected ray. Now, once we've got that, you've got your marks on each one. And now the analysis is very straightforward. What we're going to do, we're going to take our straight edge again. I like the protractor because it's just a little handier. I'm not sure if it's a left hand or a right hand, but either way. And I'm just putting my pencil basically right on the line, aligning my protractor edge so that I can trace directly over that original line and then just extend it until it hits the normal. Now you can see we're a little off here. That's fine. This is not precision work, but just do the best you can. Now, this next bit, if you don't remember how to use a protractor, I shall attempt to remind you here. So we're going to get this nice and lined up. Zoom in a little bit at least. Now, to use the protractor, the important thing is you need one of the two lines of the angle. You can choose the dashed one, which is the normal or perpendicular to the surface. And if you do that, your crosshairs right here go on the vertex of the angle. This dashed line, if that's the one you choose, should line up from the crosshair directly onto 0 degrees on the protractor. So there's the vertex, and I'm going to have to look straight down to avoid parallax. And right about there, that's about as good as I'm going to get. Again, you have to look straight down. Since the camera is at a little bit of an angle, you might be able to see the dashed line below the crosshairs. So when you're actually doing this in person, you're going to look straight down on it. Now, and if you only hold it with one finger, it'll rotate and turn. So be careful. Hold it with 2 fingers. Now, again, 2 fingers when I move this hand. So reading it, we start, this is 0, so 0, 10, 20, 30, 40 something. And if I read this, again, I'm looking straight down. This is actually between, that's 1, 2, 3. It's between the 3, the 43, and the 45. So you can't see it because it's directly over the pencil mark, but there's a mark there for 44 degrees. So I'm going to write this angle as 44.0 degrees. If I measure this angle, the vertex is shifted a little bit over here. Okay. Again, looking straight down to line this dashed line up with the 0 mark. The 90 degrees should line up here because this is a right angle. That's what defines this dashed line. It's 90 degrees from the surface. Now in here, you can see pretty clearly that the line is pretty much directly under the mark right here. So again, here's 0, so 10, 20, 30, 40, 45. Now again, depending on if you're looking at it from a lower angle, you're going to get parallax error. So you want to look straight down, and then this is just going to be 45. Okay. Now, the law of reflection, if you look at the hypothesis, says that these two angles should be equal. And 45 and 44 obviously are close. They're 1 degree apart, but they're not equal. So why? Well, there's a fair amount of error introduced with the ray here because it gets wider and wider as it gets further and further away. On top of that error, the actual reflection occurs at the back, and something called refraction occurs when the light enters the glass. So there's a bit of a change there. Now, if we were really careful, and if we were using what's called a first surface mirror, where the reflective surface is the front side, so the light never goes through the glass, these would be a lot closer together. Same thing with these next two trials. You have your line out here, plop your protractor down on your mark, or excuse me, put your pencil down on the mark first, then put your protractor and line it up with so that if you move your pencil along the protractor edge, it's going to go right over that initial ray and then extend it. So you want to make sure when you do this that you don't have your protractor up here, because you're not going to have it go far enough. You want to make sure that your protractor actually crosses that solid line.